So guys, let me take you on the another our experiment part of the DBMS, the experiment number 4. It is experiment which is belonging to the transactions uh, chapter. Okay, so somewhat I have given lecture in the classroom related to this particular experiment. Okay, so this needs your proper understanding of transaction processing and their relevant topics. They are mostly talking about the asset property. Okay. You have to achieve the asset property. You have to maintain the database. That should not uh, occur any inconsistencies. Okay. When the transaction is basically the logical unit of work which is happening on the database. And when it comes to concurrent process means that multiple users are accessing the same database at the same time. That is the condition of a concurrent process. Here they have taken example for the banking related account and their transactions. Okay. So they are talking about the particular experiment. They are telling that modern database must ensure the concurrent access to the data by multiple users does not lead to inconsistencies. Transaction processing plays a crucial role in maintaining data integrity and supporting operations like recovery and concurrency control. The system must handle the multiple transaction while ensuring the desirable properties like atomicity, consistency, isolation, and durability. You know that atomicity means the you have to achieve either completely successful or completely failed at the end. Means full or none. Okay? Means atomicity. Either it will get successful or it will get fail. If it will get successful, commit. If it will get fail, roll back. Consistency means you can say that the consistent state you have to achieve. Multiple users are coming, they are doing work, fine, but that should not collide. Okay, that should be consistent. After that, isolation, the multiple users all are accessing the same database in the isolation manner. They are achieving the independence. Okay. Durability, once you have completed everything, that should be durable. I mean, permanence. Got it? This is what the acid property. They take an account and there are some attributes, account number, customer name, balance. They take in transaction table. In that transaction ID, account number, transaction type, amount and transaction date. Okay, these are the attributes they have taken. They are telling some referential integrity and some certain conditions they have taken. And each transaction must be processed automatically without leaving the database in an inconsistent state, right? Multiple transaction can affect the same account, must be scheduled serializably, right? And these are the question we have to solve, all 10 questions. So guys, to solve this question, let me take you on the direct, your favorite platform, MySQL, right? So here I have done already, sorry, not this one, not this one. Let me share the MySQL. Yeah, this one. Okay, so I have solved already. I have taken as a banking database with the ACID property, which is satisfying the ACID properties. All the concept I used from the same book. So for your reference purpose, I have written database system with the Ramez El Masri and Shamkant Nawate, right? Now let me create the database. Created, fine. Let me just select the database, selected, fine. Okay, now first question is given, create account and transaction table. So I will create the account and transaction table. So I have taken this account table, account number, customer name, balance with respect to data type and constraint. And I am telling that the balance should not be negative, right? And engine equals to InnoDB. This is a command which we have to use for the transaction. Okay. In MySQL. So similarly, we have a transaction table, the transaction ID, account number, transaction type, amount, and the transaction date for that system time only I will use. Okay, and the referential integrity maintained so that both table will get integrated. Again, engine equals to InnoDB for the transactions. Okay, done. Till here, no problem. I should insert some data. Okay, I inserted data in both tables. You can cross check the data in the table or not. You can cross check it like by running the table. So, okay, with respect to attributes, we have some data sets in the table. Okay, this is all. Okay. And one more thing, when I was creating the table, I have taken transaction type as an enum type. In that, I have given two this one condition, deposit and withdrawal, which is defined in your syllabus, right? What practical syllabus they have given. Now, third question is two questions solved. Third question is simulate the transaction by withdrawing 500. When you are inserting the data in the tables, you observe here for the first customer, 101, 2000 rupees, for second, 1500, and for third, 3000 rupees. Okay. Now, you see here, you are deducting the 500 rupees from the 101. And since you know there are 2000 rupees in the account, so if you perform 2000 minus 500, it will become 1500, right? So our expected output will be 1500. So to do that, first I have to start the transaction to use the TCL command. Okay. So transaction is started. Now update it. Update account set balance equals to balance minus 500 where the account number 101. So in the balance particular attribute, this will get update further this particular ID. Okay. So if I will run it now, it will deduct 500 from the 2000. Now you have a 500 minus from the 2000. You are now maintaining the log by updating this insert operation. You are committing it. Yes, committed. Now perfectly fine. You can check it. Now you see it is coming 1500. Database updated. You can cross check what happened as of now. So you have done 101, 500 you have deducted. Okay, these all operation you have done. Now, fourth number question, show a schedule of two transactions accessing the same account, two concurrent withdrawal from the account 101. So you see T1 I have taken, T2 I have taken, two sessions I have taken, right? So uh, two transaction I will show here, and I will show what will be the output for that. So let me start first this transaction T1. For that you can plot same two column based graph. I mean the way I have done in the classroom, right? Transaction T1 and transaction T2, how they are reading and writing the particular concurrent processes. Okay, same way you can plot it. I have written in SQL format. Transaction is started from the session 1. So I am going to deduct 200 rupees from the our same. So earlier it was 1500, 1500 minus 1500 minus 200. How much it is? It became 1300. Fine. Okay. So here if you are running this line, your result will be 1300. Okay, fine. And you are maintaining the log by this line and then commit. Okay. Transaction is successful. So now in my database 1300 rupees. Now for the session 2, I am going to start the transaction, and transaction, whenever you are starting the transaction, it will end by commit. It will end by commit or rollback. I mean, state transition diagram of the transaction processing in the concurrent manner. Okay. You will begin the transaction. You will perform the read write operation. It could be either fail or it could be successful. Based on that only you are performing the commit or rollback. So by that only your transaction will get closed, right? So I started transaction for session 2. Then I am again deducting 300 rupees from the same customer. So if I will deduct, and previous value is 1300. Sorry, let me comment it. Previous value is 1300 minus 300 now. Okay. It will give the value of 1000 rupees. Fine. So if I will run this line, I have now 1000 rupees in the account. I will update the log. Okay, updated log and commit successful. Okay. So this transaction closed now. You can cross verify. I should get 1000 rupees only. Yes, it is coming 1000 rupees. So how it is working, I hope you are getting. You can check here what is happening here. So the way banking operations are, you see, at this time 200 rupees deducted, at this time 300 rupees deducted, before that 500 rupees deducted. This is how the bankings are working. So this is about the this particular operation. Okay, to concurrent withdrawal process you have seen now. Now you see serial and non-serial schedules. Serial schedules are always good, and but waiting time will be more. Non-serial schedule, it's actually very good, but thing is you have to maintain the ACID property, and that should not give any error. Okay, that should not create any problem that we have to maintain. So serial schedule means transaction execute one after another, no overlapping. Fine. You may go through my classroom lectures, you will understand it. Okay. T1 completes fully, then T2 will start. This is what the serial schedule. Okay. So one by one. And non-serial means overlapping. Sometime read by T1, then sometime read or write by T2, and it will go, right? So it may interleave operation, right? So this is what the fifth number that you have to write. What is conflict serializability? Conflict serializability, a non-serial schedule is conflict serializability if it can be transformed into a serial schedule by swapping non-conflicting operations. Example, if T1, T2 both update account 101, the order matters. If T1 write before T2, the result is different than the T2 write first. Okay, this is what the conflict serializability. Very simple manner I'm telling you. If T1, T2, both operations are running, okay, both transactions are running. If T1 is write first, then T2, then it must differ from the if T2 is writing first, then T2. Okay. Then only we'll say the conflict serializability. This topic I need to cover in the classroom as a theoretical perspective. That is the next lecture I will do. Okay. Time being, you write it. I will make you understand this all with the help of example. What is cascading rollback and the recoverable schedule? You understand it. Cascading rollback means when the error occur in the particular transaction and transaction got fails, forces another transaction that read its uncommitted data to roll back, right? For example, T1 writes the account 101, T2 read the uncommitted value, T1 fail and roll back. T2 must also roll back to maintain the consistency. That is what the cascading rollback. If it is not working, dirty read problem will occur. Dirty read problem will occur. Recoverable schedule means avoid cascading rollback by ensuring that the transaction only read committed data. That is what the recoverable schedule. That is what the basic ideology about it. Okay, I hope you are getting this all. If you're not getting, next class you will get clear everything in the classroom. Commit and rollback. These two are primary TCL command, right? Start transaction. Okay. So let me deduct now 100 rupees. What was the previous balance in my account? 1000 rupees only, right? So if I will deduct 100 rupees, I mean, from the my 1000 rupees, what I will get? 900 rupees, right? So my now latest output will be 900 rupees by this update operation. Okay. Now update the log, then commit operation. Okay, fine. Now in my account, 900 rupees. You can verify it. That should give the 900 rupees. Okay, fine. It is coming 900 rupees. Now you can check the what happened in your log, system log, right? Guys, now here I started transaction. I want to roll back. Okay, let me roll back. It that should send back to my previous state, right? So verify it. If it will go to the previous state, that should display my previous balance. Okay, that should display my previous balance. So So you can observe here, previous balance was 900, even though I am deducting 100 rupees, but it is not here. Basically, what should happen, which is not happening, 900 minus 100 equals to 800. But that is not happening because of this rollback operation, because this is sending back to the my previous state only. That's why you are getting the output as a 900 only. Understood now? So this is what the purpose of rollback. I hope you are able to understand this. And you can understand from here also what are the log happened here. Okay. You have done 100 rupees, this all operation, but to cross check. Dirty read problem, uncommitted data you are reading from the transactions. If isolation is not enforced, a transaction can read the uncommitted data from the another transaction. Example, T1 updates the account 101, T2 reads the uncommitted value, T1 again roll back. Then what will happen? T2 is having dirty read only, no? So let me take one uncommitted transaction. I will perform first transaction. Okay, start transaction. I'm going to add. I'm going to add this. Okay, this you understand properly. I'm going to add this. My previous balance was 900. I'm going to add it. Okay, under this transaction. So partial commit will happen here because of partial committed operation. Now in my database temporarily 1900 it is there. Okay, 1900 is it is there, and I am going to read the uncommitted data. Okay, so it is not working because this transaction is already running and I did not end this transaction by running the commit or rollback command. So it will not work out. It will not work out. Okay, so what it will do, so I want to read. I mean, here it is temporarily 1900 it is there, but that is not maintaining the actual database because still I did not run commit operation. That's why this is coming. Okay, that's why this is coming. Transaction, this one transaction characteristics can't change, you know, because it is not committed. Already transaction is started. So let me do that. Now, let me check this balance. 1900, temporarily coming 1900. Now, let me start the transaction. Let me start the new transaction. Then let me read the uncommitted data. Again, it is not accepting because another transaction already there and I did not perform any commit or rollback operation. Understood? So what I will do to fix this problem, this is the dirty read problem only. I don't have committed data, but still it is showing 1900. But our actual database is not maintained, right? So let me just commit it. Okay, let me commit it, then let me perform is uncommitted data. Okay, fine. Now let me roll back. Okay, now let me check it. What happened here? 1900 coming. What is happening actually here? I'm telling you, some confusion may be occur here. Thing is, I did not commit, but still 1900 updated. Later I committed 1900. It is there. Okay, that is our as usual process. I wanted to read through the uncommitted process, but it was not happening, not working. But you consider it as a dirty read if uncommitted data is there and you are seeing some value and that later you are committing it. Okay. If I will perform rollback operation, let's see, that should send back to the my previous state. Now let's see what output I will get. 1900. Same value I'm reading. So my previous operation is 1900 only, right? So this is what happened here. And if I will try to do that in a different manner, let's say, uh, okay, you perform it. If you are getting any other doubt, please ask. Otherwise, try to understand it. What is happening here? I will say that temporarily it is updating data. I did not perform any this one, any commit or uncommit. But after that, I am trying to read the data from the different transaction. And if it is reading some value, and later on you are making any other changes here, that will be not available here, right? Okay. Set transaction isolation levels. Okay, fine. Which allow the dirty read problem. Okay, I selected. Let me run it. Let me run it. As of now, 1900 in my account. Okay, fine. Now let me commit it. Okay, now it is committed, updated. Now read it. Okay, perform transaction and run it. You see 1900. It is coming. Okay, so this is about this one. Now prevent the concurrent update on the same account. Prevent concurrent update on the same account. Okay, start transaction. I have updated now. Yeah, I have committed. Yeah, I have committed. Now let me perform for the 10th number question. Transaction is started. Set balance from the account and for update. Okay, fine. I have run 1900 rupees in my account. Okay, fine. Select balance. Okay. Update minus 500. I want to perform it. Okay, let me perform it. Done. Let me perform the log. Done. Let me commit it. Done. Let me check what balance is now. 1900 minus 500, 1400. Okay, fine. Now select this one. Now all the operations are coming. So this is about your all the 10 questions related to guys transactions. In that basically you have to take care what is concurrency, what is concurrency control, what are the concurrency properties, the problems, dirty read problem, incorrect summary problem, dirty read problem, or else many serializability related problem. These are all given here, right? So you please go through this and just take it as a reference for a fourth number of experiment. Prepare your experiments, right? And if any doubt, please ask. I will help. Okay. You refresh the schema and you can see these all the tables which I have created. Everything is there. Okay. And the second transaction table, and in that the columns are there. Okay. Everything is there. So everything we have done for the related transaction. The algorithm you have to follow here, transaction, any transaction, basically follow the some steps. You have to start the begin the transaction, then you can be able to perform read write operation, you can be able to perform commit and rollback operation, then you have to end the transaction. This pattern you have to follow, which I have followed here, right? And how you can start the transaction? By writing a start transaction command, and if you want to end this transaction, you have to perform either commit or rollback. Okay, commit only you are performing when you have a successful result. If you are getting any failure, then you have to roll back. Okay, this is what about the transaction. In that the question number 5, question number 6, only theory that you have to write in your record. Okay, the way I have given, you write it and try to understand it. If you are not understanding, please let me know, I will explain it. Okay, I'm stopping guys. This is for reference purpose. Now this is fourth experiment completed. Overall 5 experiment I have completed. Prepare a record for last experiment, 6 number experiment related to MongoDB. We'll do that. Okay. We'll do that one more day. Okay.